So I am the deputy lead of the documentation for James Webb Space Telescope, which we call JDOX. This is an online documentation system, so we're moving away from having long monolithic handbooks that you have to scroll through and search through to find your relevant information. Instead, we have a series of articles where this information is available. And JDOX is optimized to quickly find this information through Google searches or within JDOX itself through internal searches and heavy cross-linking among topics. JDOX has a very agile infrastructure which allows us to make updates very quickly and seamlessly into the system to provide you with the most up-to-date and accurate information. It's also integrated with APT to help find more information about specific parameters. And at the end of the day, we hope that this documentation system will provide you with the information that you need to get background about the observatory, specific instruments, observing modes, so you could design really competitive and appealing proposals to maximize the scientific return from James Webb. Our JDOX philosophy follows that of Wikipedia, where every page is page one. So when you get to an article, that article is about a specific topic, and most of the information you need about that topic can be found on this one concise article. And if you need supporting information, there's heavy cross-linking to get you to that additional info. So rather than having a strict linear flow, it's more like a public transportation map where there's hubs versus a really rigid PDF type style. So if you go to the landing page for JDOX, following that URL on the top, you'll see that we've organized JDOX into what we call 4 separate spaces that define 4 separate topics. So we have a space for observatory and instrumentation, a space for observation planning, a space for opportunities and policies, the call for proposals, and a space for data calibration and analysis. And that last space will be filled out more as we get data from the instrument, and we'll have more information to be able to provide for you. So when you go to one of those spaces, you click on the link, you get to a summary page, where that top box summarizes what the articles in that space are about. We have a sidebar for quick links, and then separate boxes that could take you to landing pages for the specific topics. So here, this is an illustration for the observatory and instrumentation page, where you could get to the observatory landing page, and then information about the specific instruments. When you get to the specific instrument page, you end up on a landing page, which is an overview of the instrument. And this serves as a launching point to get additional information. So here you'll find information about the observing modes that are available for that instrument, details about the hardware, details about operations, so things like dithers, mosaics, target acquisition, and our best estimates of the predicted performance. So these are things like sensitivity and bright target limits, which are good for kind of back of the envelope calculations. If you really want to know how well you could observe something and get a better estimate of the signal to noise, you would want to use the ETC, the exposure time calculator, which we'll hear more about tomorrow. But this gives a general overview of what we've learned from commissioning and Otis testing. So all the pages on the observation space could be thought of as the data, as the instrument handbook. So these replace or could be thought of as analogs of the PDFs of instrument handbooks that many people are used to with Hubble. When we go to the planning space, this is, you could think of as a planning handbook. And here, we have lots of resources to help you all plan observations. So again, we'll be hearing more about these proposal tools tomorrow, like the ETC. But we have lots of documentation to walk users through what the ETC is about, how to go about setting up your exposure time, or to find out what exposure time that you'll need to get required signal to noise. So there's many steps involved, which we'll hear about tomorrow, including defining sources and scenes and running those calculations. And we have lots of documentation to help out that process. Similarly, we have lots of documentation for the Astronomer's Proposal tool, or APT. Same proposal tool that we use for Hubble, but things for James Webb, we have some different options and observing templates. Again, we'll hear more about that tomorrow, but there's lots of documentation that supports this tool. And we have standalone tools that we'll be hearing about this afternoon. And again, stuff like determining target visibility. If you don't want to mock up a full proposal in APT and then find out whether or not your target is visible, there's standalone tools that you could download to get that information. Our other space, again, for the call for proposals. So we heard this morning a lot about different policies, such as duplication, target of opportunities. All that information can be found under the call for proposals science policies space in JDOX. And we also have a space for what we call data handbooks. So this explains the steps that will be taken in the data reduction pipeline and the post-pipeline calibration that will be applied to the data. And as we get data from the telescope and more software is released to the community, this is where you'll go to find out how that software works, how to download it, and how to run it on your data. Okay, so there's multiple ways to navigate the JDOX site, and this is something that you'll be playing with in a little bit on the hands-on session. So once you get to a JDOX page, whether it's through going to the JDOX landing page, or if it's going through Googling a topic and getting to that page, there's many ways that you could get around. The top is the site navigation bar. So again, that will take you to those different spaces I just laid out in the previous slides. We also have an internal search bar, which navigates through JDOX itself. So if there's a topic that you want more information about or anything related to that, you could just search in within that search bar, and it'll only bring up results from JDOX. So that's a complement to Google, where you could get multiple web pages that have similar search terms. This will be JDOX specific. The top box is the summary. This is what will appears in Google when you search for something. Throughout each JDOX article, there's heavy cross-links to other articles that give that relevant information. So that's an important resource to be aware of as you're reading through and you think, oh, I want to know more about dithers that's highlighted. Click there and you'll get to that website. The figures, we have figures on pages. They might appear a little bit small when you first look at them in the article, but you can enlarge them by clicking on them. We have a page content tree. So the top box on the right, this tells you what's on that page. So it's really helpful for a quick glance when you first get onto a JDOX article to know what headings, what topics are covered in that article. And especially if you don't want to read any of the intro stuff, you really just care about, in this case, let's say what the imager is like, you click directly there, get to that point. This bottom right box shows where the article lives in the page tree. So this is really helpful in thinking about the context of that specific article. If you want to know about articles related or topics related to the topic that you're researching, this is a helpful place to look. It shows you where this article is within the page hierarchy. For example, this is the overview of MIRI, so it's part of the page tree for the MIRI instrument. And then you could see quick links to the other instrument landing pages. One thing to be aware of, though, is that this only links to the page tree for that space. So if you wanted to know how to actually design a proposal using the proposal tools, you wouldn't find this in this space, in the observatory instrumentation space. You would instead have to go to the planning space. So it's helpful within the certain space that you're in, but be aware that you would have to do extra searches to get additional information. Yes. Oh, right, yes. So here you have these little carrots. If you click on them, it'll open up to show you what else is in that page tree, what the children pages are underneath those. So for example, here, this carrot is pointing down, showing you all the pages that are within the MIRI space. And then if you click on this link, it'll show you those additional subpages. So those are helpful references to look at. Another way that you could access JDOX is through APT versions 25.1 or higher, the Astronomy Proposals tool. This is through context-sensitive help. So once you open up a JWST observing template in APT, you'll see that some of the keywords, the text on the left, is highlighted in blue. It's blue text. If you move your cursor over that text, a little question mark appears next to the cursor, and if you click on it, you're taken to a JDOX article, which gives you more information about that specific parameter. So that's another way to get help if you start writing up your proposal in APT and you want to know what your options are, for example, for dithers and what that means, you could quickly get there without having to pull up a web browser separately. We do recognize that many folks do prefer or like to also have the option of having PDFs. So we are generating PDFs periodically. So for things like the call for proposals, we will have PDFs of these separate spaces available. However, these won't be as up-to-date as online documentation. So that's something to be aware of. And for the session coming up, for the hands-on session, we're really focusing on getting folks used to being able to navigate the JDOX system. So currently, we have over 521 articles published. More will be published for the call for proposals. So some things to bear in mind of what will be coming up in the pipeline within the next month and a half. We'll have more information about the baseline Cycle 1 calibration program. We have observing techniques articles. Most of these are actually published, at least in a preliminary form. There will be some additional information within the coming weeks published for these. And these are actually, I think, a really powerful and helpful set of articles to be aware of. So these take topics of observing techniques that we might be used to from different observatories, like slitless spectroscopy, integral field unit spectroscopy, moving targets, high contrast imaging. It gives a background of what that topic is about. And then it tells users what JWST instruments and observing modes implement those observing techniques. So actually in the upcoming hands-on session for the Scavenger Hunt, there are a series of questions that are along the lines of, I want to do some observing technique, what instruments and instrument modes permit this technique, what wavelengths do they operate in, what are the resolutions, questions like that. And these pages are good one-stop shopping to see the comparison of these different capabilities at once. And again, many of these are available. Some are more mature stages than others, but these will be continued, developed over the next couple of weeks, so watch that space. science use cases. I think these are another really useful set of articles. So these pose a research question and then define which JWST observing mode is optimized to answer that research question. And then it walks you through how to set up this observing strategy in ETC, how to find sources, assign them to a scene, how to run calculations to get the answer that you're looking for, and then how to take that information and transfer to an APT. So it's a real walkthrough guide of setting up a proposal. We have a couple that are published as of a couple of days ago, so these are hot off the press. And there's more coming in the pipeline, again, within the coming weeks, so do watch that space. Sometimes for me, I know it's really helpful just to see an example worked out of how to get from point A to point B, and these science use cases do that. We have some articles being developed where instrument scientists are giving advice about best practices for specific observing modes. And we also have some video help. For people who have used HST, you might have seen that there are these APT instructional videos that help guide you through how to set up the APT, fill out the different observing parameters. And we know that these have been really helpful to the community. Some of these videos that have been developed for APT translate seamlessly to James Webb, like getting started in APT. And some are being developed anew for JWST-specific topics. So I could say that within the next coming weeks, there are videos that are being recorded to help users get started in ETC and using the APT and Aladdin overview. We expect that several of these will be up and running by the time for the call for proposals. And they'll be linked through JDOX as an extra way to help support navigating the system. So we have a lot of material already published. Lots of policy material, lots of articles walking users through how to navigate proposal planning tools like ETC and APT. Instrument handbooks are published, and we're integrated with APT through context-sensitive help. We have pretty mature drafts of data handbooks so far, and observing techniques articles, and do watch within the coming month and a half for additional support of walkthroughs of writing proposals and instructional videos. So I just want to say for the upcoming hands-on session, give some background for that. We've come up with a list of scavenger hunt questions. So these are questions about James Webb that you could find in the online documentation. And the goal is to help you get familiar and comfortable with navigating around JDOX. So there are multiple ways that you could find answers to these questions. One of the most direct ways is just go to Google and see if you could find it. One search results should take you to the right James Webb documentation article. Another way is to use that internal search bar, and also to look at articles within the page tree to find the relevant information. There are more questions there than can probably be answered. It's not a race. The questions were designed multifold. One, to help you get used to navigating JDOX, but also to really show how the different JDOX, James Webb instruments and observing modes complement each other. So there's a series of questions in there, as I said before, like which observing mode would I use to answer this question? And what are the wavelengths these operate in, and what are the different resolutions? So I think those are fun. That's a good way to learn a little bit more about the instrument. So I think those questions are fun. There are some instrument-specific questions. So if you really want to drill down into the details of different instruments and find out more information about them. We have questions like that, and a couple of questions about APT and ETC. So what I would recommend doing is look through the list of questions and see which ones seem most interesting and fun to you that you want to learn about, and see if you could use JDOX to get those answers. And if you're finding that's a lot of fun and you're not able to answer all of them, then definitely, when you get back home, go through. You can finish the scavenger hunt on yourself if you're really, really motivated to. We do have answers and links to the relevant JDOX articles for those questions, and I think those might be available after the seminar. So if you want to know what the answer is and you couldn't easily find it, you'll have that information. And then there's some time at the end to provide feedback. So the facilitators at each table will collect your feedback. So if you found, for example, that one of the questions it was really difficult to find the answer, for some of the questions, you might have to go to multiple articles to get the answer. But if you find you're just really stuck and you can't find it, definitely move on. But make a note of it. Tell us, because the way that we can make the system better is if we know what works and what doesn't work. So please do make sure to provide that information at the end of the hands-on session. And with JDOX, it's easy to make updates. It's easy to make things better. And that's what we're here to do, to give you the information to write awesome proposals and do great science. So thank you.